So we are doing the slab. Okay. Today we have to do the concept of real and apparent depth. Apparent depth due to near normal incidence. Okay. So our syllabus is all about near normal incidence. So let's say we have a medium and let's create some maybe I can go like this. So we'll believe that everyone is looking from this line. And now there are two mediums. One is the medium of observation. That's called mu medium. So mu medium is the medium in which the observer is present. And then there is another medium in which the object is present. So let me call it a mu only itself. So the mu m we can write as medium of a refractive index of medium of observation, like from where you observe things. And mu is the refractive index of medium in which object is kept. Okay. Now, what do we need to remember to solve any question like this? So we must remember that light always goes from, or you can say, direction of propagation of light. Direction of propagation of light is always taken from where to where? Object to observer or observer to object?
Object to observer.
Oh, absolutely. So it is always on the object to observer. Okay. So direction of propagation of light is also an object to observer. So the first light ray I will take directly along the normal. But with the help of single light, we cannot understand anything. And also this light will not suffer any refraction. So we need to take one more light, which is at slight angle. And now for the sake of illustration, I'll draw it slightly. Okay. Now any obliquely incident ray, this ray will suffer refraction. And now I have no idea whether the observation medium is denser or rarer. You can choose anyone. Let me, for the time being, assume that the medium of observation is rarer so that I can draw the diagram easily. So this is the incident ray. This is the incident ray. This is the angle of incidence. And if I assume the second medium to be rarer medium, it will deflect away from like this. Correct? So now this is the angle of refraction. Now what do we see? Do we see object? Do we see light? What do we see, guys? Tell me. What do we
Light.
see?
Light.
We see light. So the whole idea is simple. The light ray will enter the human eye. I'm just exaggerating this size. So for the observer, which light ray will create the image or sense of image? This light ray and the reflected one, right? So when the observer will try to retrace the path, so when you retrace the path for the object position is here, but the place where I will or you, the observer will see the object will be here, right? You can see how you can retrace the path and you can see this is the point of intersection. So this is called the apparent position of object, or simply we can call it image. So image is nothing but the apparent position of object. Okay. Understood.
Yes.
So the image is what? The moment light gets refracted, we cannot see the actual, the reality. So once the light is refracted, the direction has altered. So whatever you will end up seeing is the apparent position, or you can call it image, or you can call it the apparent position of object. It's the same thing. So you will end up seeing the image actually. I mean, image is a concept. I mean, the moment the light is getting refracted, then the refracted or the reflected light ray gives you a perception of object which you term as image, right? So the question is how to find this relation, that what is the location of image. So first of all, we have something called interface. You can see there is an interface, and this interface is the reference line. We always take the interface as the reference, and this we call the apparent position of object. It doesn't look nice. Change the color. This is called the apparent position of apparent position of the object or the image location from the interface, and this we can call as the real position of the object with respect to the interface, and that's why the name is apparent depth and the real depth. So depth is basically because normally it is a wrong term. The depth is nothing, it's not going down always, we can go horizontally also, but this is how we perceive the things. So if you look at in the water and something, what you see is the apparent position of the object inside the water, you don't see the actual. So if you look at the swimming pool from outside, it looks like it's not so deep, but the moment you get inside, it's very deep. Okay. So the floor of the pool will look quite elevated in a way. It looks like the depth is very less, because what you see is the apparent depth of the floor or the base of the swimming pool. Okay, understood. So now the obvious question is how to get this D apparent and D real relationship. Is there any way to get the relationship? The answer is yes. You can always get the relationship very easily. So what do we need to do to get the answer?
So what are we supposed to find?
The relationship between the D real and D apparent. So the light has suffered how many refraction
Sir,
in the
one.
due process from object to observer?
Sir, one.
So how many instances we need to write?
1.
1. So let's write down. So the moment you write the Snell's law, applying Snell's law at the interface, what we can write? Tell me, guys. Applying Snell's law at the interface, what we can write?
So 1. So we have to write the normal only, no? Sin I by sin R is
Yeah,
equal to.
exactly. What else you can write? So you can write mu into sine I equals to mu medium into sine R, correct?
Yes, sir.
Now, because it's a near normal incidence, so these angles are very small. I is very small, R is very small, correct? So these
Yes.
diagrams are not for the exact interpretation. These are very, uh, wrong diagram. We have to draw for the near normal incidence. So we can take it near normal and we can write sine I as I and sine R as R. And for a small angle, we can convert sine into tan, right? So now what you can see that this R will become this R and this I will become this I. And you can see a triangle OAB that will give you the whole answer. So now you can see that how we can convert the Snell's law into answer that we are looking for. So what is tan I
X
in a
by
triangle?
D real
X by D real, correct?
and X R D by sorry X by D apparent.
So we are done. So we got the answer. So what you can see that D apparent upon mu medium, I'm just inverting it to D real upon mu. So this is the easy to remember. The apparent is with respect to what? The apparent is with respect to the medium, and the real is with respect to what? Its own medium. So the ratio remains same. Okay. So that's how the answer is. So D apparent upon mu of observation is D real upon mu of object. So just to remember, the D apparent upon medium of observation is same as D real upon medium of object. So observer gives you the apparent value. It is the observer which perceives the apparent value, and the reality cannot change. The reality is always the same. But as the observer will change the medium, things will appear different. And therefore, the D apparent is D real into mu medium upon mu. And this we can rewrite as the D apparent is D real upon mu relative. And mu relative is always taken with respect to observers, which is mu upon mu medium. Is this clear?
Yes.
Yes, sir.
So the near normal incidence is giving these answer. Now again, if I say if it is not near normal, can we get the answer same? Can we convert sin into tan I? The answer is no.
No.
So in that case, we have to. I mean, in that case, the value will depend on x actually. Okay. So things will change. In that case, things will change. Is this clear?
Yes.
Now, looking at the formula, we can also see something that object has actually shifted from bottom to till this one, right? So this is called the normal shift that we discussed in the last lecture. So how to find the normal shift? It's very easy. So basic addition subtraction will do the job. So for normal shift, so can we write the normal shift is nothing but the d real minus d apparent. Okay, can we say? So what is the d real? So the d real is d. Let's call it d, or the okay d real. Let's call d real. That's easy. And the d apparent we got the d by mu relative. So the normal shift also depends on who is watching it. Okay, is this clear, guys?
Yes, sir.
Yes, sir.
So the next question is, if we have a slab of certain thickness, and again our syllabus is all about the near normal incidence. So let's say we have an object here. So let's say a person is trying to look at this object from the other side. So how the lighter will go? One lighter will go like this, but a single ray cannot create the image. Okay. So at least we need one more lighter. Let's take one more lighter. So let's say the other lighter is going this way. Now for the sake of drawing, I'm drawing not near normal, just a bigger one. Eh? You know why I'm doing this. So as a result of this slab, what will happen? The light ray will bend towards the normal because we are assuming this is denser than the air, correct? So the light ray after refraction will bend like this. Is this correct? And we have seen the something called what? The lateral shift, right?
Yes, sir.
So looks nice. So now coming to the so this light ray will emerge like this, if you remember. So now this light ray and this light ray will give you the perception. And if you want to get the perception, what will you do? You will extend the light ray backward, right? So once you extend it backward, the object will appear here O dash. Do you realize this? Maybe. So for any observer, if you observe this light ray and this light ray, imagine this is the eye. It's too big eye. Eh? Okay, don't get scared. It's very dangerous. So for this eye, the light ray will enter and where the image position will look like. So anyone looking from the other side will always see the apparent position, and the displacement is called the normal shift. And what is the logic? The logic is the normal shift has nothing to do with the object position. For near normal incidence, the normal shift is always thickness into 1 minus 1 by mu relative. Why I'm writing mu relative? Because the shift is with respect to the observer, and it depends on in which medium the observer is present. Okay. For air, if the observer is in air, the delta n will be how much? The mu of the slab only. And this formula is something that we use quite often. Also, what we need to understand that the shift always occurs in the direction of the light. Okay, you can see the light is going towards right. So when the light is going right, the shift will happen in the right direction. And if the light is going left, then shift will occur in the
Left.
left direction. So now there is one condition like what if the mu relative is less than 1? Now when this is true, when this is false. Now there is a situation in which the mu relative, because the medium is denser and the object and the slab is like rarer than the medium itself. Can we create something like that?
You can you repeat again?
So what if the observer is in denser medium and the object is in the rarer medium? I mean, if the slab is rarer compared to the observer's medium. I mean, let me draw it and you will understand. So let's say we have a glass. So this is called air slab. So I have just made a cavity in the shape of a slab. Okay. So I have
Yes.
made a cavity in the shape of the slab, as you can see. All right. And if this is the case, then your whole idea will flip actually. Now, whatever you are thinking will become opposite. But mathematically, it is simple. So let's say this is the object. And the light is going, one is going this way. So that's I'm ignoring because this will not give me anything. And the other light component is going this way. Now, after reflection, the light ray will go away from the normal or towards the normal. Tell me guys.
Sir, away from the normal.
Correct?
Yeah.
It will go away from the normal. And after that, the light ray will go
Towards.
parallel to the original one.
Yeah, yeah.
So let me do this line first, extend this line. and this light ray will move parallel to this, no?
Yes, sir.
So if you extend this light ray backward, as we have been doing, the object is shifting in the reverse direction.
Yeah.
Can you see that? So what does it mean? So the object can shift left or right depending on. See, generally, when we say slab, it's like inherently believe that the slab is denser medium and the observer is in air or some medium which is a rarer medium. But the reverse could also happen. But do we need to worry about this? The answer is no. I mean, our formula is what? Our mathematical formula is thickness of the slab 1 minus 1 by mu relative. Now, of course, this is the mu and this is mu. I mean, luckily, this is air actually, so it's 1. I can have anything. So what I was saying that if the formula we can write as 1 upon mu by mu m, which is mu m by mu m. Now, what if mu m exceeds the mu itself, the delta n will be negative. Correct? That's logical.
Yeah.
If the surrounding itself is denser than the slab itself, the reverse phenomena will take place. So our negative is saying that as per the older expectation, it will move along the incident ray. It will move opposite to the incident ray. That's a interpretation of negative sign. So when you get a negative sign, you have to shift the object backward this way. Is this clear? What we are doing?
Yes,
In
sir.
optics, based on the perception, let's say every time when you have derivation, it is inherently believed that the lens slab and everything else is denser. So we have one particular perception because of that particular relation. But in JEE advanced or in any tough question, you have to fight with your intuition because they will reverse the scenario. So they may create a prism with air. So I can take a big glass slab and I will cut a prism inside and I will remove that part. So it will act as a air prism. Now everything will reverse because the prism is now rarer than the, and I may fill the prism with some liquid, maybe some kerosene. So I have a kerosene prism, and the kerosene prism will be definitely less denser than the glass. So things will change. So in such scenario, you should understand how to interpret the answer. So you always keep one perception, but a negative sign will make the process reverse. So forward becomes backward, up becomes down, and so on. So the normal shift is the property of slab, and generally, in general, the shift occurs in the direction of incident ray, assuming the slab is denser than the surrounding. For reverse scenario, the shift will be opposite to the direction of incident ray. And if you want, you can put into a note. So tell me guys, what should I write here in note?
So that it depends on the surrounding.
Yeah, it should depend on the surrounding of course. So we can say generally the normal shift occurs in the direction of, so generally the normal shift occurs in the direction of incident ray, assuming the Ri of slab is greater than Ri of surrounding, medium, else vice versa. So right now you have to just stick to this idea. Don't worry much. So the normal shift is something which is very, very important, and every slab is capable of doing it independently. And the good thing is that the shift always have the fixed value, and the shift always remains independent of the position of the slab. So the second idea that we should be careful about is normal shift remains independent of position of slab. Any other idea that we need to be careful about? I think uh, normal shift formula is applicable for near normal incidence. Okay. So the normal shift occurs in the direction of incident ray, assuming the Ri of slab is greater than Ri of surrounding, else vice versa. If this is condition is met, so if the light ray will come on the other side, it will again shift. So while okay, I'll give you another example. So imagine if we have some sort of concave mirror on this side, and eventually the light will travel and will hit this mirror. And after hitting the mirror, let's say the light ray is tracing back, it is going back somehow. So I am not showing the incident part, I'm just showing the reflected part. Can you draw the remaining diagram? How the light ray will arrive at the axis? Assume one other ray I'm taking as this way, which will go just like this. So draw the remaining ray diagram just to realize that how things will happen. Everyone draw it. In the ray optics, you have to draw the rays. That's simple.
Yeah, sir, I drew it.
So,
Then, sir.
so it will
Only
bend
the
towards the
upper
normal.
one we have to,
Let me do one normal first. So the ray will bend,
yeah,
but eventually will go parallel to itself.
yeah, parallel to the original.
So now the expected location of the ray was this. So this is called the image formed by the mirror. And this is the final image. Now mirror is not a, see, for mirror, the image is forming here only. Because mirror is not aware of the fact that slab is in between and it will shift my answer. So when we are solving the problem of mirror and slab problem, once we have the answer for the image position of the mirror, we have to shift from our side to get the answer, actual answer. Do you realize this? Yes or no?
Yes, sir.
Hello, hello. So the question is generally why I'm teaching this, because we need to understand how to solve question of mirror and slab. So there's something called mirror and slab problem. Mirror and slab problem. So it is solved in two stages. First, shift object, because you have to shift the object also, because slab will shift it normally, and then the mirror will perceive the apparent position of object as the object. And the apparent position of object will be the object distance for the mirror, right? And the step 2 is what? Solve uh, solve for image position using mirror formula. And to find the final position of image, again shift the image of mirror. So first you need to shift the object to find the object position due to, I mean, for the given mirror. Then use the mirror formula, then solve the question, and then again shift to get the other answer. This is the 3-step process. Shift, apply. So it's the process we can mark it as something like this. Shift, mirror formula. So I can say back shift. If I say this is forward shift, then this is the back shift, and then you are getting the answer. So let's see some question to understand. But before that, we'll solve some basic questions from the real and apparent depth. And before we solve something, let me show you something interesting. So imagine there is a pond or lake or river, and we have some fish here. So this is the fish, huh? And there is a bird called kingfisher. Have you heard this name?
Yes, sir.
So generally this is air, and this is the let's say denser medium. I'm just making it simple. Can you draw the ray diagram? Because the fish is the assuming fish is the observer, and fish is looking at the kingfisher. Now, how to draw the kingfisher? I cannot, but I'll draw only a small portion. A dangerous kingfisher. I don't know. It is maybe I can draw to mark it like can I see kingfisher? How it looks like? Difficult. Huh? We all know kingfisher. Okay, something like this. Okay, a big. This is even bigger. Then it's not very large. Okay, as my drawing skills are really good. Oh, this is something like creature of beyond imagination. Anyway, you can imagine the rest part is up to the imagination. So now this is the kingfisher, and this is the fish. And now what I'm saying, the fish is the observer. Kingfisher is in air. Okay. So the question is, what is the, okay, now let's say the height of the kingfisher from the interface is h, and okay, so first of all you just draw the ray diagram to find the apparent height of the kingfisher with respect to fish. Now fish is the observer. So question is, find the apparent height of the kingfisher with respect to fish. Draw appropriate ray diagram. Okay. So first you draw the ray diagram because you can feel it better. See how the refraction is affecting the location.
Yeah, sir, it is the bird will appear below the position.
So how you have taken the light ray?
So
Light ray.
first from the bird to the fish without any
Okay, fine.
deviation.
So this will just go like this. Huh? So this is the light, no? The bird and fish is listens. And the other I will take as at some angle like this.
Yeah, sir.
So this light ray will turn towards the normal or away from normal.
Towards.
So if you trace back this light ray and this light ray, where you will get?
Yeah, sir, it will be above the bird. Sorry.
In my case, I cannot draw it further, but you can understand.
Yeah.
So it will be much above the actual position. So there is a dilemma. The fish always believe that the kingfisher is quite far away. And the dilemma is easy. The kingfisher always believe that the fish is quite closer. And these two, the dilemma is such that the fish will try to go towards the surface to have some oxygen. Okay. And the kingfisher will think that, okay, while going, let's have some breakfast. And so when the kingfisher dives in, because of the experience, the kingfisher always dives inside the water and catches the fish because the apparent depth is, of course, less than the actual. And so kingfisher knows inherently that it has to dive actually. So maybe the fish is not smarter. The kingfisher is smarter. And anyway, fish doesn't care that they will come and kill because that idea is not with the the fish. Maybe the fish is having less brain. I don't know how much brain is having. But so what is the answer, by the way? What is the apparent height of the kingfisher? The H apparent is how much? So for the fish, what is the apparent height? Tell me, guys.
So we can use the same formula only.
Yeah, of course.
So the actual h by mu.
Are you sure? H1 mu is less than H, so you are saying it is less than H. Eh? I'm saying it should be more than H. Okay, do one thing. I mean, of course, there's a formula we can solve this question. Can you derive it the way we did for the previous question? The IR triangle, then you can assume X, then write the formula and then get the answer. Can you do it now?
Yeah, sir.
So draw a separate diagram in which you draw it properly, extend the line, make sure that you have enough space to intersect, use the triangle and then get the answer. So do it from scratch without using the formula. Harshit is not there. Eh?
Yeah, sir. He had joined in this term, and now he's in.
What's the answer?
No, sir.
Why?
So last time it was easy because you had made the whole geometrical figure.
Yeah, so that's why, you know, in geometrical optics, until anyone is not mastering the drawing part, it is never going to be easy for you. Knowing the formula is one thing, but if you want to enjoy the geometrical optics, you should draw the lines, the ray diagrams, and think about it, why, how it is drawn, how it is derived the formula. So try this out, put some effort. Hello guys, not able to do? Is it so difficult?
So the
Sir,
diagram.
I'm trying, but I'm getting nowhere. I got the diagram, but
Yeah, so this is the angle of incidence, right? This is the angle of reflection. If this is I, so this is I. If this is R, so this will be R, which I haven't drawn completely. But one thing I know that must be the H apparent, right?
yeah,
And this is your X. You can write as a very simple answer. 1, because you're entering from the air, light is coming from air. No? So 1 sine I equals to mu sine R. So tan I equals to mu tan R for near normal incidence as we have discussed. And the tan I will be X upon H, and tan I will be H apparent, sorry, X upon H apparent. So the H apparent turns out to be mu H. Simple. That's logical, not because it is bigger than H, so it must be the product actually. So even if in case even if in case you get forget the answer, remember the logic. If anything is being looked from the denser medium, so from denser it appear farther, from rarer it appear nearer. So denser, farther, rarer, nearer. So NRDF, uh, NDRF. Oh, yes. National disasters. NDRF is famous, no? So National Disaster Rescue Force, I think. Something like this. No, no, National Disaster Rescue Force, I think. Maybe Response Force, I think. Response Force, National Disaster Response Force, correct. Okay, so in near, rarer, and denser farther, maybe like this, but it's really bad. Common sense is better. Now, if you remember the formula which we derived using the formula, so we derived that the H apparent upon mu of observer, H real upon mu of object. So apparent is from denser medium, from water. So H apparent, and the mu of observer is mu only. H real is H, and mu of object is 1. So this is the simplest way to remember. Is this clear, guys?
Yes, sir.
Yes. So this is easy. Like no matter how it is given, you can always do this. And what else? The other way of thinking is this was the okay the fish example. This is the observer. Let's say not this observer is in the denser medium. That's it. So this is the observer. The new observer is me, and the objective was here, right? Something here. So we know that if you look from here, the air will act as a slab, right? You can think this as slab. This is the alternative way of thinking. Imagine a air slab of thickness h. So what is the formula for the normal shift, if you remember? The normal shift is how much? Thickness into 1 minus 1 by mu relative, if you remember.
Yes.
And mu relative is mu of the object upon mu of the observer, if you
So,
remember. So the delta n comes out to be 1 minus mu. And because this is the shift, so there are two ways. And I'm assuming this entire term is positive, although I know it's negative, but let's say this is positive. The apparent height will be how much? The actual height minus shift. This is how we do, correct?
Yes.
yes, sir.
H minus h into 1 minus mu, how much is the answer?
H mu.
Let's say I'm smart. So I know this is negative, so I'll make it first. So how? Minus mu minus 1 into h. So the minus is saying that the shift will be backward of this value, correct? So the h apparent will be how much? What I write? I write h plus, correct?
Yes.
Same answer. So it is like if I know that the shift has occurred in the backward direction, I will add the value because the minus is only saying that the shift is in the reverse direction as you expected. And if I treat that term as positive without manipulating anything, then the shift will be along the light ray because light ray is coming down. So I have taken the shift downward. So the h apparent is h minus the shift, which is again giving me mu h. So there are multiple ways of thinking the same problem. The normal shift is one way of thinking. How shift helps in getting the answer. Is this clear? Yes or no?
Yes, sir. Please.
Yes, sir. Clear.
So if we have multiple slabs, then shift will be multiple times. And each slab will have their own shift value, correct? So imagine we have one slab. Let's bring two slabs. Two slabs with them. Uh, okay. Let me create a slab for observer as well, right? Always a good idea. So just to make it nicer. So this is the mu of observer. So this is mu1, mu2, mu3, and let's say thickness wise, this is T1, T2, and this is my object. So now the light ray has to move from the object towards the observer. Here is the observer. Just to give you other perspective that even if I have a slab here, so T4 will matter, yes or no? Will T4 matter for the object and the observer?
So no.
No.
No, because light ray will never cross the medium number 4 while going towards the observer. So what really matters is that which slab comes in the path of the light ray when the light ray is going from the object towards the observer. So anything which is not part of it is of no use. You can just discard. Now there are two ways to solve this question. So the first way is like the D apparent will be the total D minus the total shift. So once you apply the shift formula, you can get the answer. And other formulas, of course, we can directly write the formula. The D apparent upon that will prove also that the mu of the observer is thickness is given T1 by mu1 plus T2 by mu2. So this is the simple way of getting the answer. Let's try to get it from here. So the D apparent connector is D real, which is T1 plus T2 plus T3 minus. Now, as we know that shift is independent of position of the slab. So how much is the first slab will shift? I know the answer T1 1 minus mu medium by mu1, correct? If you remember. And therefore, if you multiply, what is the answer? You can say T1 this you can see directly we are getting the answer. And then this we can convert into the form that I said. T1 on mu, U2 on mu2. So this is the direct formula which you can derive using the direct formula. So you can use this direct formula, or you can use the actual location minus the shift of each value. Now, why the shift formula is easier to apply? Because sometimes the medium may be rarer, so it will take care of all the values, whether it's positive or negative or whatever. And always remember that if no medium is given, you can take air as a slab while doing this, applying this formula. For air, the mu we can take as 1. Okay. So what I'll do is, I mean, not I will do, you guys will do for me. I will help you in deriving the formula because I think uh, still you haven't got the confidence of drawing the diagram in array optics. You're trying to learn this chapter through by cramming the formula and using it for solving problem, but I really want you to solve and draw it actually. So let's make it simple. I mean, for you, it is simple question. O is object and observer is this way, this side. Okay. And let's say D1, D2 is the thickness or depth or whatever you can say. And okay, you have to derive the answer of the apparent depth. So here, how the light ray will move? So one will move directly like this, nothing will happen. Okay.
Yes, sir.
The other will move at some angle. Okay, thicker one.
So what is the relation between mu1 and mu2?
No relation. So you can choose whatever you want. So what I'll do, for the sake of simplicity, I will take in the path, the mu will decrease. But that will give me a nice diagram, right? These are all mathematical assumptions. The moment you assume it, it is, and it is giving you nice diagram, and you can solve it easily. That's it. So draw along with me. The first ray will go like this, but it will suffer refraction, yes or no?
Yes.
And it will move away from the normal, yes or no? I mean, just let's assume away from normal.
Yes. If mu1 is less.
Yeah, if mu1 is less. And see, in mathematical derivation, eventually we'll get a mathematical relation, and so it will not matter. So it really doesn't matter. And it will bend once more. So this is I1, R1, R1, R. That's fine. And you know what will be done next? You extend the line to meet the vertical line. So you have to write how many times the expression?
Two times.
So this is the first image, and this is the second or the final image. And you are supposed to find this value, that's the DR. So of course you will not get the answer at once. You have to do a bit of hard work. Can you solve this now by drawing the remaining diagram? Or do I need to draw everything? Okay, let me do this. Still derive it. Okay, I've drawn the entire diagram which you need. So derive the final D apparent from this ray diagram. Okay. You can use the approximation because it's a near normal incidence. Ignore the diagram which we have drawn here. Like I have drawn, of course. So try this out. At least you will realize what we are doing. Huh?
Yes.
Anyone knows who is Shivanshi Jain? Is she in your batch?
Sir, I
Sir,
don't
we
know.
don't know.
Sir, will there be X and X dash in the answer?
No, of course not. I think you have taken enough time. I should solve now.
So please 2 minutes or 2 minutes.
Right is Snell's for 2 times and convert the answer.
Yes, sir, I did it. Now I am looking at the figure and trying to solve it.
You can take this as y and you can write. I'm writing directly answer. Mu2 into sine. So I can just write tan. Mu2 into I1 x upon d2 equals to mu1 into x by y, and then mu1 into r1. This is r, this is r, and this is r1. So r1 will be x dash upon d2 plus y is air into x dash by d apparent. So x dash will cancel out. So d apparent turns out to be d2 plus y by mu1, and the y turns out to be y by mu1 is d2 by mu2. So y turns out to be d2 mu1 by mu2. Uh, I have made some mistake. D1 plus, no, this is d1 plus y. So d1 plus y, right? So we got the y values. We can add d1 plus d2 mu1 by mu2 by mu1. If I divide, what I'll get d1 by mu1 plus d2 by mu. And that is a logical answer. So you can do it for two, and then you can do it for any number. So in general, the way to write this term is d apparent upon medium of observation is summation of di upon mu1. That's it. Easy to remember.
Yes, sir. So the only mistake I made in the formula was 1 into x dash by d1 I wrote by mistake. So I was
Okay.
not getting the d apparent term only, so I was confused.
Oh, okay. But still you tried. That's a good thing. See, if you want to get rid of the effort of mugging up the formula, just learn the derivation, and if ITJ will ask throw any random question, anyone with the habit of drawing the diagram and solving from scratch will get the answer. Someone only knows the formula, you will come across situation in which no direct formula will be applicable. So you will get stuck. Okay. So this was the refraction from the plane surface, and the apparent should be applied only when the refracting surface is flat. Just Okay, so in general, this is easy to remember. You can apply for any number. So although we derive for 2, but as you know, you can apply for 3, 4, 5, and whatever. So I hope the concept of normal shift is clear. How to find the normal shift and how to uh, find the apparent and real. Let's do something interesting. So we have two medium. Which I am representing by two different colors. And we have the object one here. And from this interface, the separation is let's call it D1 or X1. What do you want to say? D or X?
D.
D. And the refractive index is mu1. Question is find the distance of O2 as seen by O1 distance of O1 as seen by O2. So when O1 is the observer, which distance will appear as it is? So when you enter the water, you can see the inside easily, right? Clearly, without any apparent. The apparent only happens when the light suffers a refraction. So for observer O1, the D1 will appear D1 or different from D1. What do you think?
So observer one, it will be D.
For observer one, D1 will appear D1 only, right? But
Yes.
D2 will appear something different, D2 dash. Or you can say the apparent value of D2 as seen by the. So for the A case, the distance of O2 as seen by O1 will be. So distance of 2 as seen by 1, we can write as D1 plus D2 apparent. Because you cannot see D2 completely, right? You can see D2 apparent value. And to get the apparent value, how to find? So D2 apparent upon the medium of observation equals to D actual upon the medium. So D2 apparent is how much, guys? Tell me. D2 mu1 by mu2.
Yes, sir.
And then the D2 turns out to be D1 plus D2 by mu2 into mu. There are many ways of writing this. You can write this way, or you can take mu1 common. It will look like D1 by mu1 plus D2 by mu2. Okay. And we are doing in terms of slab and all. You know, the idea of slab. If you remember. So this we can convert into a two slab problem by thinking that this is not a good. You can think this is one slab and this is another slab. And who is the observer? The observer happens in the medium one. So the O2 will appear at a apparent depth, which we know formula, right? So if O2 is the object and O1 is the observer, light ray will travel like this. Correct? No. Are you getting it? What I'm saying?
Yes.
So D21 will be, so D21 upon, and the observer is having the refractive index mu1. So this must be equal to D2 by mu2 plus D1 by mu1. And if you rearrange, you will get the same answer. Correct? Yes or no? No.
Yes.
Yes. And similarly, D12, like the distance of one as seen by the two. So we can add this by mu2 equals to the direct formula. So D12 turns out to be D2 plus mu2 by mu1 into D1. The way you can think slab formula, or you can think as the apparent real, it is up to you how you want to understand this. Is this clear?
Yes, sir.
Are you sure?
Yes.
So
Yes,
now
sir.
the next question will be like, if this is moving with velocity, so let's say these are two fish in the aquarium, and these two aquarium is kept side by side, and the first fish is moving with velocity v1 and second with velocity v2, and then I want to find the relative velocity of one as seen by two and two as seen by one. So these are two possible questions. So the next question, which is obvious, find the relative velocity of one with respect to two and two with respect to one. So can you tell me the answer? So the distance relation and the velocity relation will be similar. Replace the d by v, you get the answer, right?
Yes, sir. We have to just differentiate, but I'm that. We
Yeah,
on.
and you have to be very careful when you differentiate, then you have to see whether it is increasing or decreasing and something. Okay. All right. So what is the separation in general between these two objects? So distance of two as seen by one is, so one is the observer. So we know mu1 into x1 by mu1 plus x2 by mu2, right? See, easy to, and then we differentiate. So this is the velocity of two as seen by one, and this is minus v1 by mu1. Why minus? Because x is decreasing, right? They're coming towards the interface. We always take the interface as the reference, right?
Nice.
So the x1, x2 are measured from the interface. Interface is my reference. And as the fish will move, x will decrease. So we have to put minus sign and then again a minus sign. And that's it. And so the minus sign will come outside. You can see the answer is this. And now the minus is saying that they are approaching. Okay. So if the relative is negative, it means the separation is decreasing or diminishing with time. So this is the velocity of approach. So we want to approach is how much? Then you can remove the minus sign. Therefore, we want to approach will be how much? Something like this, yes or no?
Yes, sir.
Then you can change the direction. Let's say you can one taking right and left and something like that. Okay. And the fish can also start moving at some angle also. That's also possible. So you can start solving the question from SC Verma, and you will be able to solve the next maybe 10, 20 questions. I need to check SC Verma. Okay, all right. So now you can start solving the question of refraction. And there's really nice question from in SC Verma. Solve it one by one, sequentially, and practice the ray optics. That's very important. In the next lecture, I will solve some more questions actually. So next lecture will be purely numerical solving only. So I will show you that how to solve questions, and we'll see some more advanced questions. Okay, okay, guys, bye and take care.
Sir, I
Yeah.
have two doubts and I mean in two questions.
Mhm.
Can you
So,
solve the one question, sir?
yeah, send me. No?
Oh,
So it is related to the optics or something else.
sir, no, something else.
Okay, so let me stop this lecture because this recording will go for the upload. So let me stop it, and then you can rejoin. Okay? Or you
Yes.
can share the question. I'll just share the solution. Okay.
Sir, and one more. Sir, in when we write the Young's modulus, in which we write the stress, we write the extra force, right?
We are at the
Extra force. Like in circular motion, we write the mv square by r as the extra force.
extra force.
Sir, in uh stress, while writing the stress in Young's modulus,
Okay, okay. Young's modulus stress. Yeah, yeah. Okay,
we
so
write
in,
the
in the circular motion question, no?
ha
Hmm.
we write the extra like mv square by r as the extra force.
No, that is not that is not the extra force. If it is rotating, then that is it will have the centripetal force. So T d theta equals to MAC, and if it is having some charge or something, so d theta minus repulsion force equals to MAC. So you're writing the formula net force towards the center equals to mass into centripetal acceleration. So either you can write the net force equals to mass into centripetal acceleration, or you can write net force equals to 0, in which you take the pseudo force, which is the centrifugal force equals to m omega square r or MAC. Okay. So it is the part of circular motion. We are not writing extra. We are writing the laws of motion. And for any circular motion, how we write the laws of motion? Tell me.
So yeah, that I know, but
Yeah.
sir, okay. Then in one question, there was one string and one block was hanging onto that string. So
Mhm.
while writing stress, I have to take the tension in that stress formula,
Yeah,
right?
of course, of course.
And the
Yes,
whole
yes.
magnitude of tension or any component of tension.
Is it moving or is it at rest?
No, it's in equilibrium.
So then only tension come. Na? How the extra force will come? Extra force is due to the rotation, na? Due to circular motion, right?
Okay, sir, understood.
What you are saying, extra force is the rotation, m omega square r, is the rotation part.
Yes, sir, understood. Sir, I sent you the question.
Yeah. The question of 14 or 15.
Sir, both are related to passage one. 15th one, but
So if the density of air is, yeah, in this case, what we do is the
sir, I
rate.
was not able to write the Bernoulli's equation for the 2 points.
Okay,
How
okay,
to-
no, no. In this case, the air water mixture will go outside, right? The air and the liquid mixture both goes outside. So what happens is generally the air pressure will drop, which will suck the water from the container, liquid from container to the pipe, and then the incoming air will mix with it and will go outside. So generally the reduction in the pressure is due to the kinetic head, or you can say the kinetic pressure, which is half rho
half rho
v
v
square.
square.
Okay. So the half rho v square, you can say rho half rho v square is equals to half rho v square, but the rho is liquid and v liquid and rho, I mean this uh,
So
liquid
I
and
should
air. Yeah.
conserve the pressure at which points?
No, we are
At
not
the no.
no, there is nothing like conserving pressure here. We are writing the relationship directly at the junction where the liquid will meet the air. Okay. So liquid from the bottom container will meet the air at a junction. You can see there is junction in the pipe.
Yes.
So at junction, the air will create a pressure drop. Okay. And the pressure drop is how much? Half rho A square.
Half rho a square. Yes.
And half rho air V air whole square. And that pressure drop will suck the liquid to that location, which is mgh, or you can say rho gh, the increase in the potential of the
Sir,
liquid.
H is negligible.
Yeah, h is negligible, so you can write, so it's a proportional to value. They're asking proportional value, right? What is
Yes.
proportional? You can ignore the h. So what is the relation of the velocity? So speed at which the liquid is spread. So the speed at which the liquid is spread is same as the speed of air actually, isn't it?
Yes. Sir, can
Half,
you?
you can just write like this. You can write so whatever is the length of the neck. So VA is how much? Into some constant 2gh whatever.
Sir, but when the water will rise up, wouldn't there be any velocity for the liquid?
Yeah, that we can ignore compared to the velocity of the air pressure. So air is thrust out of this hole, and then water will mix with the air, and then it will move along with the air. So the velocity of the mixture will be as per the air velocity, through which we are throttling out the air. Okay.
Okay.
So the answer will be, I think C should be the option. Can you check?
Yes, that is the answer.
And what is the other question?
So no, this one. Done.